This is a training video for the superconductor on the Mobius Strip demo. Once it's working, this is what it looks like.
Go ahead.
Pretty cool, right? Here's a little bit about the setup. The track is already built, so you just have to put it on a table. Next, pour some liquid nitrogen into a container like this guy is doing in the picture. A plastic container about the size of a shoebox should be about right. So once you have about 2 inches worth of liquid nitrogen in the container, take the wafer and submerge it in the liquid for about 2 minutes. The first time takes the longest, but when you need to cool the wafer again, it should only take about a minute or so. Once the wafer is cold, use the tongs to take it out of the liquid nitrogen and put it over the track. If you get curious, you'll find that the wafer is actually safe to touch at this point, but it will be very cold. When you put the wafer over the track, it will just levitate automatically. It's pretty magical, and the physics is rather complicated, so I will let George explain it. He says it basically comes down to the fact that changing the magnetic points on the wafer takes energy. So it does the easier thing, which is to levitate. So here he is.
Okay, so in here we have an example of an yttrium barium copper oxide superconductor, YBCO. Here you go, YBCO right there, YBCO. So it's a YBCO superconductor wafer. Now inside of this thing, you can see it's very thin. All right. So when this material gets very cold, it becomes a superconductor. The main property of a superconductor is not that its resistance goes to zero. Instead, the main property is superconductors are perfect diamagnets. They repulse all magnetic fields. Okay, so what happens with a type 2 superconductor is we get something that are called these fluxoid regions. The magnetic field is able to pierce through, so these metal wires indicate the magnetic field, and this region here is called a fluxoid. It's a region of the superconducting wafer, that's this white styrofoam thing, that allows the magnetic field to penetrate. So you can see it's kind of going through on both sides there. All right? It kind of makes this into Swiss cheese, basically. Now here's the interesting thing. If we take our superconducting wafer and we put it near this magnetic track, there's lots of magnetic field. This is a north pole up, this is a south pole up, north pole up, south pole up. So the field lines go out of north and into south. They're these very strong, very warped field lines. When you get a superconductor on there, it's going to create many, many fluxoids coming through here, making this thing look like this. All right? Now, it turns out it takes a lot of energy for fluxoids to move. So much energy, in fact, that this thing can hover like this, suspended above, or suspended below. It'll hang there like this. Now, me doing this like this isn't very exciting, so what we've got in here we have a superconducting wafer that's been cooling off in some liquid nitrogen. Basic liquid nitrogen safety rules apply here. Okay, so inside of here is one of those, and what we've done is we've wrapped it in Mylar and paper towel, alternating about 6 or 7 layers, so that it stays cold for a little bit of time. And when you put it on here, you can see that it floats above, and if you can get this angle right here, you'll like it. Oh, whoops, can you help me out? Yeah. Put it on there and give it a light flip, not too fast. Watch it now. Oh, whoops. Check this out right here. That's too much. Okay. Push that back a little bit. Whoa, pretty cool, right? And then because it's a Mobius strip, if we get this thing going, it should go all the way around and be on the one side of the track. Poor Jason Schmidt, not getting any work done today because I'm totally destroying his lab for science. All right, that's basically it.
Okay, to wrap up the video, here are a few key things that you can tell the audience. And instead of reading them off to you, I think it's best if you pause the video and read them over. I highly recommend memorizing the stuff in yellow. And that's it for this video.